Alright, so I wanted to make a video covering this activity 15.2 from lesson 15, which was called the remainder theorem, because there's a question very similar to this on the test, and I know that we haven't really touched on this kind of thing in quite a bit. So I wanted to review this idea, just so everyone feels good about doing this for the test. So at first this question is going to seem kind of daunting, but then once you understand the idea behind it, it'll actually be really easy. So it says, consider the polynomial function f of x equals x to the fourth minus ux cubed plus 24x squared minus 32x plus 16, where u is an unknown real number. So here's u. We don't know what that is. It says if x minus 2 is a factor, and this is important, if x minus 2 is a factor, what is the value of u? Explain how you know. So at first you might try long dividing. You might say, okay, put my x minus 2 there, and then my x to the fourth minus ux cubed plus 24x squared minus 32x plus 16. You could try doing it that way, but it's really not going to get you very far. And you can try doing this and see if you can figure it out. But this is really not the best way to go about it, and I don't even know if it would really work. So we're not going to do this. Although that's a perfectly valid idea to have when you're given a question like this. Okay, so what are we going to do? So if we think about this in a different way, we know x minus 2 is a factor. Instead of thinking about it as a division problem, we can think about it as, okay, if x minus 2 is a factor, that means what? For example, if you think about the graph of this function, what does x minus 2 is a factor, what does that mean about the graph? And what that means is x minus 2 is a factor, tells us that 2 is an x-intercept. And if 2 is an x-intercept, what does that tell us? That tells us that f of 2, or when you plug in 2, you get 0. Because that's what an x-intercept is. It's whatever you plug in, whatever you can plug into the original function to get 0 is an x-intercept. So we know that f of 2 equals 0. Okay, so now how does that help us? Well, now we know that x to the fourth minus u of x cubed plus 24x squared minus 32x plus 16. If we plug in 2 into each of these x's, we're supposed to get 0. So let's do that. So 2 to the fourth minus u times 2 cubed plus 24 times 2 squared minus 32 times 2 plus 16. We know this has to equal 0. That's what this f of 2 means. We just plug in 2 for all the x's. So we know f of 2 equals 0, which means that this equals 0. Okay, so now let's just work that out some more. So 2 to the fourth power is going to give us, like, let's see, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So 16 minus, and then we have 2 cubed is going to be 8, so 8u plus 24 times 2 squared. 2 squared is 4. 24 times 4 is going to give us 96. And then we have minus 32 times 2. That's going to give us 64. So minus 64 plus 16 equals 0. Okay, now we can combine all of our like terms, which is all of our constants here. So that's going to give us, let's see, why don't I just pull out my calculator here. Alright, so we have, let's see, 16 plus 96 minus 64 plus 16 is going to give us 64, this is telling me. So that means that this is equal to negative 8u plus 64, and that's going to be 0. So now from here we just need to solve for u, and that should be pretty straightforward to you at this point in your math education. So we can subtract 64 from both sides. That tells us, I'm just going to move this over here, that tells us that negative 8u is going to be equal to negative 64. And that's going to tell us, we divide both sides by negative 8, we're going to get u equals 8. So u is 8. So, yeah, there's going to be a question very similar to this on the test. So just the main thing to remember is if you know x minus something is a factor, then you know that when you plug that number in to the function, you should get 0. And that's really key to figuring out a question like this. Please let me know if you have any more questions over this specifically. I know this is kind of a daunting problem and it can be kind of confusing. So please let me know if you need any additional help with this, but hopefully this video was a good review over that kind of thing. And this is getting at the idea of the remainder theorem, which is that whatever your remainder is when you have, for example, I'll just write it on the back of my packet here. So your remainder when you divide your function, we'll say f of x, when you divide f of x by x minus a, where a can be any number, is the same as what you get when you plug in a. So it's the same as f of a. And we see that when we're told that, for example, x minus 2 is a factor, we know that we should not get any remainder when we divide, which means that our remainder is 0, which is what we get when we plug in f of 2. If x minus 2 is a factor, then when you plug in f of 2, you should get 0, because the remainder when you divide by x minus 2 is 0, because it divides evenly. So that's the idea behind the remainder theorem, and this problem that we just did is just getting at sort of the basics of that theorem. So yeah, hopefully this was helpful, and again, please let me know if you need any additional help with this kind of thing.